Alright, so we're going to talk about some free fall. During free fall, an object is only under the influence of gravity. There's no air resistance or forms of propulsion. Therefore, the feather was not in free fall because there was significant air resistance acting on the feather. Now you might think there's air resistance acting on some of the other objects as well, and that is true. However, it's negligible. It's so small it doesn't really interfere, but when you have a feather or a piece of paper, the air resistance is going to be significant enough that we're going to say the object is not in free fall. Other things that you can't have in order to be in free fall is a form of propulsion. So the airplane and the jetpack and things like that cannot be included as objects that are going to be in free fall. So let's look at this. Gravitational acceleration or free fall acceleration is negative 9.81 meters per second squared. That is what it is for all objects. All objects accelerate at the same rate when they are in free fall. This means it doesn't matter what object we drop from the top of this cliff. After 1 second, it will be going negative 9.81 meters per second. After 2 seconds, it'll be going negative 19.62 meters per second. How do we get from here to here? We simply added another negative 9.81. Same here, add a negative 9.81. Okay, 3 seconds, it'll be going negative 23.43, and so on and so forth. But it will always be going, objects, doesn't matter what the object is, if it's in free fall and it's a rock or a ball or anything that's in free fall, this is how fast it will be going after a designated amount of time. Now, what if the object isn't simply dropped, but instead thrown upward? Well, let's look at this. In this example, we're going to say the acceleration due to gravity is negative 10. We're simply rounding it from negative 9.81 to negative 10 so that we can look at these numbers and they're nice and simple. So, throw the ball up. Up is positive, so it's being thrown with a positive 30 meters per second velocity. After 1 second acceleration, we round to be negative 10, so 30 plus negative 10 gets us to 20. After another second, we'll be going 10. At the very peak, the velocity will be 0, and this is true always. You throw an object upward, at its peak, it is going 0. It's not going up or down. Then, as soon as that instant passes and it starts going down, you can see we're going to continue to acceleration of negative 10, so it's negative 10 after 1 second, negative 20 after 2 seconds, negative 30 after 3 seconds. Of course, these seconds here are the total time that's passed. Another observation that we should be making is this. 20, negative 20. 30, negative 30. 10, negative 10. At equal elevation, so when they are at the same height, the object has the same magnitude for its speed. The same speed. It's just that one, it's going up, the other, it's coming down. Up, down. This means that if I throw a ball upward and it comes back down, if I threw it with a speed of 15 meters per second, if I catch it at that same height, it's going negative 15 meters per second. This is useful information when we start to solve some problems. Also, knowing that the velocity at the top is 0 is very useful information as we start to solve problems.